Hi, my name is Chris Kieser, and I work at PSOC Applications, and we're going to be talking about the analog capabilities of PSOC-3 today. This is a demonstration which shows PSOC-3 as a transimpedance amplifier and the ability to accurately measure values down in the nanoamp range. Here's an overview of what's going on inside PSOC-3. We have a transimpedance amplifier. We have a delta sigma analog to digital converter. We have a voltage DAC to set a reference value. We have a current DAC, which we use during calibration, and then we route the signal out to a pin, which allows us to connect up to the transimpedance amplifier and measure external currents. We built a demonstration board which allows us to generate an external current sink so that we can show what the capabilities of this circuit are, and also the ability to hook up an external current sink so that we can compare accuracy between the two things. This is the demonstration board that we built. This right here is the external current sink. These jumpers here allow us to select the feedback resistance for the current sink. These jumpers here allow us to set different voltage references. The effect is these jumpers act like setting a base current. This setter here works at 10 nanoamps, 100 nanoamps, 1 microamp, 10 microamps, and 100 microamps. And these jumper settings over here allow us to do multiplication by 1, by 2, or by 5. So the setting that we're currently in is a base setting of 10 nanoamps and multiplication by 1, which says that this would be sinking 10 nanoamps. The fourth jumper setting on this side over here allows us to select this 10-turn trim pot, which allows us to vary the current over a range. This would be a range of about 100 nanoamps and 1 microamp, and so this would allow us to do a continuously variable current sinking value. This connection right here is board ground and allows us to connect an external current source meter if we're interested in measuring accuracy. This is the TIA pin that we showed on the whiteboard earlier. It connects directly to the PSOC, and this is the input into our external current sink. So what we have here is a Keithley source meter and an Agilent multimeter, and we're just going to kind of demonstrate the capabilities of these two pieces of equipment. We recently looked at eBay to see what the Keithley meter was running for, and we saw it running around $3,300. This was calibrated in January 28, 2009, and this calibration is up in May 20th, 2009. So these are both recently calibrated and up to date. And what we're going to be doing is just showing a demonstration of what we'll be doing also on the PSOC, and we're just going to try to compare what this syncing capability is and what this is able to read. So what we'll do is we're just going to set this up to sync 1 microamp, and so this is showing that we're syncing about 996 nanoamps, which is roughly 1 microamp. And here the multimeter is showing 1.01 to 1.02 microamps. So here we've got it set up to sync 150 nanoamps, and we've reached the limitations of the Agilent meter. It's around the area. It's 140 nanoamps in this reading, 150 nanoamps in this reading, up as high as 180 nanoamps. And as you can see right here, we're certainly reaching the ends of the capabilities of our Agilent meter. Did the Keithley source meter up to our demonstration board. We bypassed our precision current sink at this point. Right now all we're doing is using the external Keithley meter and sending that signal directly to the PSOC-3. So all of the circuitry is being bypassed at the moment. We have our Keithley meter set up to sync 150 nanoamps, and on our PSOC-3 we're showing 152 nanoamps. And so what we'll do is I'll just go ahead and go through a range of values, and we'll look at what the response is with our PSOC-3. So now we'll just do a quick comparison of what we were doing with this meter over here on the PSOC-3. So we've got it at 150 nanoamps, and as you can see, we're showing 150 nanoamps, but we'll add 1 microamp to this. So now we're syncing 1.15 microamps. and P-SOC 3 is showing 1.147 nanoamps. Let's go ahead and bump this up to 1.35 nanoamps, or 1.35 microamps. So there's 1,347 nanoamps. And okay, connected the Keithley meter, and we're just going to use a shorting connection to hook up our precision source meter. And you can see that it's reading 0 nanoamps because we're not actually sourcing or syncing anything at the moment. And now we're going to connect up our precision source. Now right now this is set to sync 10 nanoamps. We're reaching the limits of my precision current sync here. Actually, it's not able to get within this area and still be really accurate. So as you take a look up at the screen, it's showing about 18.6 nanoamps, and then I'm going to go ahead and jump it over to the 20 nanoamp setting, and as you can see that, you know, we're right around the hairy edge of what this is capable of syncing. So this is 24 nanoamps what it's reporting, and we'll move it over to the 50 nanoamp range. And there we go, we got 55.9. Now this isn't a perfect current sync. We're not able to dial it in down to the last few nanoamps, just really because these are 1% resistors, and just using off-the-shelf components. This is a 2N3904 transistor and generic analog amplifier. Let's go ahead and move it over to the adjustable reference, and we'll play around in this nanoamp range and take a look at what we can do. So I'm just going to be adjusting our trim pot value here, and